Science. China plans to build a giant chip factory driven by particle accelerator. Cutting-edge technology to manufacture microchips could give the Chinese semiconductor industry a way around US sanctions. China is exploring new avenues to bypass restrictions on lithography machines, which are used in the production of microchips. Using particle accelerator to create a novel laser source, researchers are laying the foundation for the future of semiconductor fabrication. Plans are now underway to construct a particle accelerator with a semi-conference between 100 and 150 meters, 328 to 492 feet, roughly the size of 2 basketball courts. The accelerator's electron beam will transform into a high-quality light source for on-site chip manufacturing and scientific inquiry. The team from Tsinghua University is in active discussions with authorities in Xiangan New area to select a construction site for the cutting-edge project. Contrary to commercial players such as Advanced Semiconductor Materials Lithography (ASML) chip-making machines for export, the Chinese project aims to localize manufacturing by building a colossal factory housing multiple lithography machines around a single accelerator. This innovation could foster high-volume, low-cost chip manufacturing and potentially propel China into a leadership role in the industrial production of advanced chips, known as 2nm nanometers chips and beyond. Bending light to fit technology. Solar power is an excellent way of generating electricity, whether that's for an off-grid home or for the power grid. With no moving parts, maintenance is relatively low, and the downsides of burning fuel are eliminated as well. But as much as it's revolutionized power generation over the last few decades, there is still some performance gains to be made when it comes to the solar cells themselves. A team of Stanford recently made strides in improving cell efficiency by bending the properties of sunlight itself. In order to generate electricity directly from sunlight, a photon with a specific amount of energy needs to strike the semiconductor material. Any photon with higher energy will waste some of that energy as heat, and any with lower energy won't generate electricity. Previous methods to solve this problem involve using something similar to a prism to separate the light out into colors or energies that colorate to a specific type of cells calibrated specifically for those colors. This method does the opposite. It changes the light itself to a color that fits the semiconductor material. In short, specialized materials convert the energy from two lower energy photons into a single higher energy photon, which then strikes the solar panel to create energy. By adding these color-changing materials as a layer to a photovoltaic solar panel, the panel can generate more energy with a given amount of light than a traditional panel. The major hurdle, as with any research, is whether or not this will be viable when produced at a scale. And this shows promise in this regard as well. There are other applications for these materials beyond photovoltaics as well, and the researchers provide an excellent demonstration in 3D printing. By adding these color change materials to resin, red laser can be used instead of blue or ultraviolet lasers to cure resin in extremely specific locations, leading to stronger and more accurate prints.